All right, this is the final example, and this one is going to have a radical that we actually can simplify. So I wanted to show you at least one example of one that could simplify. So let's go ahead, and we already know that this is going to be a problem that has complex solutions. So we're going to cut straight to it. Remember, this is our a value, the first number, right, that has that leading term of what has a power of 2. And this is going to be my b value. And this is going to be my c value. So notice I just labeled them very quickly, right? A little bit faster than last time. We're still going to use our formula of x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to go ahead and we're going to work this out. So I'm going to put negative, but instead of a b, I'm going to go ahead and just write parentheses plus or minus the square root of b squared minus 4 times my a value times my c value all over 2 times a. And let's go ahead and just get straight to business and start substituting these values. Now my b value is going to be positive 4. So I'm going to put a 4 in there. There's another b value right there, so I'm going to put a positive 4 there. And then I need my a value. I have two a's, one after the 4 and one after the 2. And my a value is 5, so I'll put a 5 right here and a 5 right here. And then our c value is positive 2. So that c, I'm going to put a positive 2 in there. And let's go ahead and work this out and see what it looks like. So I'm going to distribute my negative sign. That becomes negative 4 plus or minus the square root of. And once again, I'm not going to put the radical sign in my calculator. I'm just going to put the numbers that are inside of it to see what that value is. And then we'll deal with it in just a moment. So let's put that in. I have parenthesis 4 close parenthesis squared minus 4 times 5 times 2. And it gives me negative 24. So now we have negative 24 over 2 times 5, which would be 10. All right. Now, just like I told you before, once we get to this point, we want to see, can this radical be simplified? And so what I'm going to do is, right before we even check to see if it can be simplified, I'm going to go ahead and rewrite this one more time. Let's go ahead and take out that I value, right, the imaginary number. So I'm going to have the square root of negative 1 times the square root of positive 24. And this is all divided by 10. So I'm going to check and see, can the square root of 24 be simplified further? So let's check it. Now I'm going to draw my factor tree. Now when I'm simplifying this, you may be able to look at this. Some of you may recognize there's a perfect square in there, and you may be ready to pull it out. But me personally, I just look at it and say, well, I think it can divide by 2, and I'm going to use my prime factorization to simplify it. So I'll do 24 divided by 2. That's my favorite go-to number because it works in most of them. And notice 2 can go into 24 12 times. So this would be 2 and 12. And then I'm going to see, well, can I divide 12 by 2? So 12 divided by 2, and it gives me 6. So I get 2 and 6. And if I wanted to keep going, I can say, well, let me see, can I divide 6 by 2? And I can. So I'm going to divide it, and I got 2 and 3. Now, I recognize immediately that 3 is a prime number. And any time that this bottom right number becomes either a prime number or a perfect square, you stop. That's how you know that you should stop and don't break it down any further. Now, I'm going to go ahead and I'm going to write these all as radicals being multiplied. And when I say all of these, I'm just talking about the numbers on the left and the bottom right. And I'm going to circle them as I write them and cross them out. So that was square root of 2 times square root of 2 times another square root of 2 times the square root of 3. And the reason I can do this and I can expand it this way is because if I multiply it out, 2 times 2 times 2 times 2 times 3, it's just going to get me back to 24, right? Which is what we started with. So all I did is break these down real quick, because what I'm trying to do is find groupings, or groups of 2 radicands that are the same. Because remember, a radicand times itself is itself. In other words, square root of 2 times square root of 2 is just going to give me 2. Now, since both of these can't be broken down any further, I'm actually going to just have to put them back together. So 2 times 3 is going to give me 6. So this just becomes square root of 6. So if I wanted to further simplify this and write it in its simplest form, I end up with 2 square root of 6. So I just simplified this radical here, and now I'm going to use that in place of the square root of 24. So let's go back over here where we were. We got a couple things going on over here. That square root of negative 1, that's just an I value, right? So that's just an I. This square root of 24, we just simplified it and found that in its simplified version, it's 2 square root of 6. So I'm going to put this as times 2 square root of 6. And then I'm going to bring down my negative 4 plus or minus all over 10. Okay, so things are starting to look different here. And we're going to continue working on it now. Alright, I'm going to move my camera down just a little bit. And let's deal with this 10 in the denominator. And I'm also going to rearrange this. Notice I have the I in front of the 2. Typically, if we have a number outside of a radical, we put the variable after the number, because they're all being multiplied anyways. The order in which they multiply doesn't matter. And so we're going to move the I after the 2. So I'm going to rewrite this as negative 4 over the denominator of 10 plus or minus 2I square root of 6 over 10. So really it's like if I have two fractions. Now I'm breaking it up because for some reason when I leave it together like this, I just have a hard time dividing out the 10 into both numbers. And we need to simplify these fractions. So for instance, negative 4 over 10. If you don't know what number simplifies it, and that's one I'm very familiar with, so I already know that 2 going to 4 and 2 going to 10, which is going to give me negative 2 over 5. But if you didn't know that, right, just get your calculator out, do alpha y equals, enter. So you can go ahead and get your fraction bar, and it'll simplify it for you. You can put negative 4 over 10, and as long as you're using that fraction bar, it'll show you that it should be negative 2 over 5, which is what I already said, right? But this one I've seen it a lot, so it's just like I almost memorize it every time I see it. I feel like it's common. So I have negative 2 over 5. And then I'm just going to extend this, and then plus or minus. And now I'm going to handle this second fraction. Let me just put an arrow here. And when we finish, go ahead and simplify the 2 over 10. We'll write our final answer. So I'm going to do the same thing. I'm going to hit alpha y equals, enter, to get my fraction bar. And I'm going to do 2 over 10 and see what it changes to. And it changes to 1 over 5. Now remember, there's always an invisible 1 in front of the I. So we don't actually have to write a 1 here. We can just simply put the I, because that is 1I. And then square root of 6. And then that 10 turned into a 5. Right? So imagine we had two different fractions here. Right? So I'm just going to rewrite it a little bit simpler. So our final answer is x is equal to negative 2 plus or minus I square root of 6 over 5. Right? And I kind of written this like two different fractions, but I was just treating this as two different fractions and just writing them beside each other. And now I'm going to write my final answer out all nice and neat. So my complex solution here, solutions are negative 2 plus or minus I square root of 6 divided by 5. And that's your answer. So hopefully with these three examples, you have an idea of how to do these now, and you can work the rest of the problems on your own and be ready for your test coming up. And let me be sure not forget to put this as x equals. Two plus or minus I. because our quadratic formula that we used in the beginning, it's always x equals that quadratic formula.